you made no notes on the nuances and design that we were talking about. And it just kind of seemed like you're doing it all in your head. So at this point, what I'm thinking is you have some rough idea of what you want to do,
Hmm.
but there's nothing concrete here. And just kind of feels like you are waving a magic wand and hiding all the details. I think actually just writing out very briefly what you're going to do, like as a pseudocode, and say what approximately what values you're going to be using would be extremely helpful here, I think. So, hey, what's up?
I'm doing well. Thank you so much for conducting another mock interview with me. I really appreciate it.
Yeah, for sure. I understand that we did a coaching interview before. How have things been since then?
Well, since then, I finished up my data structures class, and I think I feel more comfortable with some of the more complex things I was a little iffy about before. Um, yeah, and that's pretty much how I've been. And congratulations on hitting 1,000 subscribers. That's really incredible.
Oh, thank you. Yeah, I appreciate that. So you finished your data structure class, and I think I remember saying that it would be very difficult for you to actually out- get onto Onsites without having completed that before.
Hmm.
Yeah, but I remember you didn't do that badly in the in our mock interview, actually.
Yeah, I think I had a hard time with recursion.
Mm, makes sense. Okay, so have you received any offers to go on site or done any phone screens since then?
Yes, I've done a few on-site interviews, and I have some other interviews lined up as well.
Okay, that's really good. Did you feel that the stuff that we talked about in our coaching session helped you on these on sites?
Yeah, I definitely think so. I think that in terms of like breaking down the problem, like you were talking about, articulating my thought process was very helpful. Um, and thankfully, I haven't really encountered um any like recursive problems or anything like that with like graphs or trees or anything like that. It's mostly just been a race. So I've been kind of focusing on having like a breadth of familiarity with like different data structures and algorithms.
Okay, so you've mostly been just working with arrays for most of these on-site problems and very few graphs. Okay. So you said you struggled with recursion. Did you feel like any of the tree problems that you were given were particularly bad for you?
No, I wasn't given any tree problems.
Okay, so very few graphs and no trees.
No graphs, no trees, like for the
Oh,
on-site.
okay, that's surprising. I would expect at least like one or two trees. Um, what companies did you do on-sites with?
Well, I only did an on-site with Capital One.
Okay.
Um, and I did first round interviews with Facebook and Microsoft.
Ooh. How do you think you did on that?
Well, for Facebook, I didn't pass. And for Microsoft, I passed the first round, but because I did interview like this month, they don't have enough capacity for a final round, so they're gonna update me on that. And I have another round with Amazon coming up.
Ooh. Okay, so let's see if we can get you at least one of those offers.
Yeah, that would be really great. Thank you.
Okay, for sure. So let's move on to like why you didn't pass the Facebook interview. What did you feel like you particularly struggled on?
Well, I think during the Facebook interview was also just personal problems had been coming up at that time, so I hadn't really focused too much on studying. But with Capital Ones, I felt like that was a better representation of how I was doing. So essentially, for Capital One, I got stuck on a heap problem and a stack problem because I hadn't really gone over those yet.
Mm,
Um, but I think for those types of problems, I feel a little bit more comfortable with them. And since then, I've also been trying to get better with like trees and graphs as well.
I see. Um, okay, so what I can do is since graphs and trees haven't really been coming up, and it seems like you're what's called weak on heaps. Which kind of problem do you want to do? Do you want to focus on heaps, or do you want to focus on trees and graphs?
To be honest, I'm not quite sure because I've been going through like Amazon's questions and they tend to have a pretty even mix of like trees, grass, and heaps.
Hmm.
Um, so I don't really like have a preference on that.
Okay. So then let's go with trees because I'm thinking that most companies ask you about trees to begin with anyway, more so than graphs. So we'll just go with that. Although I do like quite a few tree problems, I think in most of my coaching videos, but another one couldn't hurt, hopefully. Okay, this problem could be good. So I want you to do is test if a binary tree is height balanced. And what I mean by height balanced, I mean if the left side and the right side of a binary tree, only the height of those height differ by one or less.
Okay. um. Okay, so I'm really just looking to see if a binary tree is balanced. Will I be given an input test case?
So you want a test case? Huh? Okay. So let's say I gave you something like. So let's say I gave you something like this, 1, 2, 3, and then let's say the 2 belong to the 5. Or actually, no, this isn't balanced. Suppose that this was here, right? This would be balanced because the height of the left side and the height of the right side only differs by 1. But if I gave you something like the formatting on this is a little weird. So ignore the value of the numbers here, but let's say that you have something like say this belongs to 7, and then this one belongs to here. Suppose you had something like this, and then the 5 here and the 6 belongs to the right side of 5. Then this is not going to be balanced. Does that make sense?
Yeah, that makes sense. So going back to the first example, if on the right side, if 5 had like another subtree, like for this first example, then the tree wouldn't be balanced as well, right?
Yeah. So if this 2 did not exist, then this would not be balanced.
Okay, that makes sense. Okay, and am I always guaranteed to be given a non-null case? Like as a non-binary?
Your solution ideally should be able to handle this very elegantly, shall we
Okay.
say.
Um, okay, well in this case, it seems like I'm really it really boils down to finding the height of each node and then checking um okay, so just to backtrack a little bit. So it seems like I'm really finding the heights of the subtrees of each node and then seeing if those heights differ um by 1 or less. Or in this case, I guess if they differ by more than 1, then it would be an unbalanced tree. And then we know that for the node that those subtrees belong to, that would be the unbalanced node. So I'm just going to copy over those examples to kind of like reiterate what I'm trying to talk about. So if I have like a 7 there, then the unbalanced node would end up being 3, like even before I get to the 1. So essentially, I'm comparing subtree heights for a node. And because I'm comparing heights, I really want this to be, I believe the term is a bottom up recursion. I'm not quite sure, but what the thing that I'm trying to show is that the heights that are being returned, they're going to start at the leaf node and then they're going to bubble back up towards the top. So because I begin height calculation with the leaf node and bubble back to the root, And as I'm doing that bubbling back to the root, I'm going to hit a node, hit like an unbalanced node, meaning that its subtree heights are not balanced, or not subtree heights, um, height differences are greater than 2. If their subtree height difference is like greater than 2, then that would be the unbalanced node. And once I reach that unbalanced node, I would know that I have an unbalanced binary tree.
Okay, so you have begin height calculation with leaf node and bulb back up to root. Okay, hit an unbalanced node where the subtree height difference is greater than 2. Okay. Let's clarify. So when you say a subtree height, what exactly do you mean? Are you comparing it with the node, or are you comparing left side, right side?
I'm comparing the left side and the right side. And then when I return, so in this case, right? In this case, like I think it would be better if I just walk through an example. So in this case, like if I compare the heights of the 7, well, there's 0, it's balanced. And then I return the 7's height back up to its parent 5. I compare the heights for 5, so it has 7 as its right, 0 as its left. So it has a height of 1, height of 0. That's also balanced. Then I return 5's height to 3. And then when 3 sees it's the height of its left and right subtrees, it sees that its left has a height of 0, its right has a height of 2. And then 3 knows that it's an unbalanced node. And then at that point, I'd be able to return that this is an unbalanced binary tree. So I'm really comparing the heights of the subtrees for a particular node. And then if it's not an unbalanced node, because at an unbalanced node, I pretty much just stop and like return that it is like, not balanced. But if it's not an unbalanced node, then I'm returning its height back up to its parent.
Okay, so let's clarify. So you're going to return back the height, right?
Yes.
So then how do you determine, like in this case, like as you ran through, you hit 3 and then you found out that this was unbalanced. What value do you send back in order to mark that this is unbalanced?
Okay, in that case, so thinking about how the actual recursion would work, what I'm thinking of as like a naive approach is I could probably just have like a global variable, some sort of like Boolean flag, which I can pass on to my function. And then because it's like a global variable, like if I do all my recursion in like a helper function, I have a global variable in my main function. Then once that global variable the flag turns false, then I could just return that flag. And if it remains true throughout, then that flag would just, be true.
Just keep in mind though, your function can only really return one thing, right? You either return a integer, which is the height, or you return true, false.
No, sorry. I think that I think I didn't quite explain that. The recursive function would be returning the height. However, because the recursive function itself is returning the height, I'm thinking that I could have a Boolean flag in my main function, which is that flag.
I see. So you're gonna have a main function and then a recursive helper.
Yes. And then because my my Boolean global flag, whatever, because that would be returned false at this point, I already know that. And then I would just return that flag in my main function. Like I wouldn't be using any of the values returned from my recursive function in my main function. My recursive function would only be within itself to change the Boolean flag if needed.
Okay, that's fair. But don't you think that you might be doing a lot of extra work in case you found it to begin with? Because if for instance if all this on the right side ended up being on the left side, and then you looked to the left first, then there's no need to find or actually, let me put it this way. Let me try rephrasing what I just said. Suppose you did your search here, you started at the 7 node, and then you worked your way all the way back up to 3, and you found that it was imbalanced. There would be no need to look on the left-hand side because you've already got your answer. If it's unbalanced on one side, then that's already your answer. You don't need to do any additional work. But the fact that you put it in your helper, kind of wouldn't that potentially create a lot of extra work that you don't need to do?
Yes, I would be like recursing unnecessarily once I've already gotten like once already like my flag would have turned false.
Okay.
So ideally I'd want to just stop my function when I reach this point. And I'm trying to kind of think of a way that I could do that. Because I still want to, because I still want to return the heights. I guess one other thing I could do is I could have the heights be in the separate recursive function. And I could have the other recursion checking the for the balances be in a separate recursive function. And once I reach the unbalanced node, I would just return false in my main function. So everything would happen in my main function with only the height being the recursive function.
Okay.
So the function would stop once I reached the unbalanced node.
Okay. So it seems like you have an idea.
Okay. In this case, I'll begin coding. And just to clarify, I didn't clarify this before, but the output value is either true or false.
Correct. Yes.
Okay. Okay. Dev. And then I'll be using Python as my language. And to clarify, I'm only given like the root for my function. Okay. So I'm going to go ahead and I'm going to create my helper function for the height first.
Okay, I thought you said you're going to have this all in the main function, right? In order to handle the extra work case.
Oh, no, I said that I was going to calculate the height in a recursive function and then checking the balancing that would be in the main function.
Okay. Now I'm curious to see where this goes.
Okay. So for the height, let's just put that there. So if the root is none, then the height would just return 0 as its value. But otherwise, I want to return the max of the roots left, the roots right, plus 1. So the 1 would be including the node that's given. So essentially for the height calculation, once I reach the leaf node, like I'm recursing all the way down there and I reach the leaf node, then I'd be adding 1 to the parent.
Keep in mind this max function is of root left, root right. You're going to need to define, right? Because this function here, root left dot root and root right are going to be nodes. So.
I'm sorry, I didn't quite catch that.
So this max here, you're plugging in a node, which is root dot left and root dot right. So this max function, you would normally be comparing two integers, right?
Yes, I'd be comparing the height of the root left and the height of the root right, because that's where like the recursion would come in, where once I would reach like the null node of like a leaf node, I return 0 so that like the actual leaf node's height, because in that case the height of the root right and the height of the left are both 0, so the leaf node would be 1 and that would recurse back up so that its parents are able to get its height.
That's fair.
Okay, and then for the balance tree, well, would it be correct to assume that if the root is none, then I mean that is like a balanced tree?
Yeah, I mean, it does fit the definition. So,
Mm-hmm. Okay, and then otherwise I want to calculate the height of the left and the right subtrees. And then if I see that their difference um, is greater than 2, is greater or equal to 2, then I return false. Um, and then that would just kind of boil back upwards. Um, so I could call this left. So the height of the left, and then I get the height of the right.
okay.
And then if left, if the absolute value of left minus right is greater than 1, then I would return false.
Mm-hmm.
And then I'm just going to review the recursion again to make sure that I'm understanding what I'm doing properly. So if I start off with this root node and I'm calculating its height, so that means that when I'm doing the height of the left, I'll be going all the way down, recursing here until I reach like the null node. And then I'm going to be calculating, well, I'm going to start off by calculating the height of this left tree. So its left and its right are both 0. And then I see that, it doesn't have, it's not unbalanced. So that's fine. And I'm done like evaluating that. And afterwards, I'd be going to the right side, and the right would not traverse, sorry, but it would recurse down all the way to the 7.
Mm-hmm.
And then when I reach the 7, I get the heights of its subtrees. So that's also balanced because they're both 0. Height of 1 goes back up to its parent 5. And then parent 5 sees that heights of its subtrees have a difference of 1, so still that's fine. So then I send its height back up to 3, and the 3 sees that its left height is 0, and that its right height is 2, and then at that point I would stop and return false. And then otherwise, I would just return true if it hasn't returned false at any point. And as a, concerning space and time complexity, because so time complexity wise, I am going through all the nodes. So that would be of n time, considering that n is like the number of nodes. And then for space complexity, that would be of height of the tree. So if we do have a balanced binary tree, then best case scenario would be O of log n because it's balanced. So it would just be like the left height and the right height of two sides. However, if it's skewed towards like the left or the right, like for example, if instead of having the 2 there, I didn't have that 2, I only had the right side, then it would be worst case scenario O of n because all the nodes would be like in the recursive stack.
I see. So your justification for order, was it order H, is because of the function call stack?
Yes.
I see. Okay, I understand. That seems reasonable, but and overall, your answer does work.
Okay.
One thing I'm concerned about is that, again, going back to what I said before, there's a lot of additional work that you're doing.
Mm-hmm.
So, for instance, ideally, what would happen is that once you hit this 3 node, you would no longer do any more work. But the only reason this works in your particular example is
Mhm.
because you evaluate left and right first. If I swap these two around, then you would be going down right and left. You know what I'm saying? Because it's like what the moment you hit this three node, I
Uh-huh.
think the ideal situation would be that you no longer recurse anywhere else, but your code actually does recurse through everything. So,
Yeah.
is there a
Um,
way you can cut out any additional work?
okay, let's see. Well, um, hmm. So just to clarify, the issue is that I'm doing additional work because, like I said before, I am traversing through all the nodes when really I want to stop when I reach the unbalanced node, right? Um,
Correct, because if it's unbalanced on one side here,
it would be unbalanced like for the main root as well,
mm-hmm.
and for all of its parents. Hmm, yeah, because like I am doing like left and the right. So if this was like on the left instead, and this had been on the right, then I'd still be doing it all the way across.
Well,
Hmm.
yeah, also because just by the pure definition of it is like even if I put like a numbers here as well, just the fact that this subtree down here is imbalanced just means the definition doesn't work. So
Yes, I think I understand. I'm just trying to think of a way where I can kind of cut down on the recursion that I'm doing. Well, I guess something I could do is that I could check if the height of the left, so if I can check kind of like the height of the subtrees before actually calculating the difference. Um, I think that would that be a particular way of doing it? Let's see. Okay. Sorry. So so I think what I want to do is that while I'm doing this like DFS algorithm, I kind of wanted to cut across reaching that unbalanced node. So maybe if I can kind of just stop while I'm calculating the height of its subtree, for instance, um, then I would be able to cut down like on recursing to like every node in the tree.
mm-hmm.
Okay, so I'm thinking that something I could do is um hmm, maybe like I could do the recursion for the height while I'm doing the checking for the balancing. So that way, as opposed to I think getting all the heights to recurse back upwards as I'm calculating the heights and I'm going back up, then I can kind of come across that on my way there, as opposed to like moving this to like a separate recursive function.
Okay, so you can combine both of them. But then how do you manage the values that you're returning in the recursion?
Yes. Okay, let me think about that for a second. Yes, I think that was something that was being discussed earlier where I
Mhm.
still want to return this variable. But I also want to Oh, I guess what I could do is when I'm calculating the height of the root of the node, when I see that when I'm calculating the max height of the left and the right, if I see that this height has a difference greater than one, um, then I could stop within this recursive function.
Hmm.
So if the height of the root dot left is greater than the height, well, sorry, if like the absolute value root dot left minus um the absolute value of the root dot right um is greater than one, then I could return false, but I also want to actually return the heights back upwards.
Hmm. So how do you return? So let's put it this way. How do you return two values?
I mean, I could return them in a list.
You can do that in, you can do that in Python. Yeah, sure. Yeah, I was thinking like a pair, but sure, you could do a list of objects.
Yeah, I could do a list of objects. Like I was saying before, I could also have like a global variable, pass that in as a parameter, manipulate it. Um, that's also something that could be done.
I'm
But
cool with either.
I'm sorry.
I'm cool with either. Yeah.
Okay. In that case, yeah, I think I'll just go with the global variable root.
Okay.
Um, I'll just call this unbalanced or balanced. Sorry. So balanced equals true. Um,
You put this in the function, so this is. Oh, I see what you're doing. Okay, you're gonna pass it in.
mhm.
Okay.
And then balanced, and then balanced equals. I think Python actually has something called like a non-local variable, which makes it global. So if balance equals false, then that would be seen.
Okay.
Um, but essentially, if it's unbalanced, then I could return the false. But if it's not, then I just return the height for further calculations. Um, so then when I go up to here, when I'm getting the height, so if I can, oh,
I
see,
want to point something out. Is that when you're doing that evaluation for balanced, I would, wouldn't you want to do it inside this height? Because you're still calling this recursion here. I mean, that's the core problem.
yes, that's sorry. And then I could, oh, sorry, let me just see this again. Yeah, so, because I have my global variable over here and I'm changing the flag to being false. So um, if it's false, I guess I could return like a negative one or something, or I could just return false back up to like the main function. And um, if the main function ends up returning false, or if the main function, let's say, like returns like negative one if it's false, or if it returns false, like if the recursive function returns that in the main function, then I know just like stop calculating the heights. Stop like doing like the recursion for checking the balancing.
Okay, that's fine. But you when that you would probably want to do that outside of the if statement because this is gonna you don't have room to what's it called do that evaluation if you just write it into the condition like this.
Oh, are you talking about this
Well,
evaluation here?
yeah, because even if you put balanced here, where are you evaluating it? Because this keep in mind that this function here is your recursion
Yes.
and and you're calling it every single time here. So
Mm-hmm.
even if you set balance to false and return -1 or whatever, and in fact, I think this is wrong because this will mean that your absolute value could be -1 minus uh you know it's just I don't think that this return value is quite correct either. Doesn't look right because if this value is 1, then you end up with a value of minus one, which is 2. And then that'll also trigger it as well, which I guess it's okay. I guess it's
But
right. But if
it's
the height is 0, then this
yeah.
doesn't work. So what I'm saying here is that you probably need to break this up.
Okay, well, I thought that because this is absolute value, that if I return something like -1, that would signal me that whatever I'm getting is like invalid.
Well, let's say that we do receive a -1 invalid here, right?
Uh-huh.
And then let's say we receive a 0 here, just in case like this root right is null.
Mm-hmm.
The value of this expression, this absolute value, would be -1 minus 0, which
Mm-hmm.
would be 0. Wait, sorry, -1 minus 0, which would be 1, right?
Mm-hmm.
So
Uh,
then that would fail the check, even though you said, hey, this left here is invalid, but this right here, because there's nothing on the right side, then that somehow made it okay.
mm-hmm. Yeah,
And
that makes
very
sense.
specifically, this would apply to your 3 scenario here, right?
Mhm. Okay, well, in that case, I think I'm a little bit stuck on
That's fine.
returning I think I'm just a little bit stuck on returning like multiple values within the same recursive function because I am handling both the height values if it's still balanced.
That's fine.
I'm handling not sending a height value if it's unbalanced. So I think something that I could probably do is perhaps I could just stick with sending like an array instead where um I could just send in 0 and then I could send in what balanced is.
I think you're missing the point here, but I think I have enough to talk about if you want to stop the problem here.
Yeah, I think that would be great.
Okay, cool. Yeah, so I'm going to say for the most part, that you did actually pretty well for the very initial part, actually.
Mhm.
I look at my notes here. I don't even think we need to really talk about the what's it called, the first few minutes. I think the first 15 were actually quite good. So actually, let me share my screen with you. So like kind of like I would say the first few minutes here are okay. Like you're going through the example, you're trying to figure out like what exactly needs to be done. You're defining everything that needs to be figured out. What I didn't like was that when we were talking about all this, you were just walking through this, but you made no notes on the nuances and design that we were talking about. And it just kind of seemed like you're doing it all in your head. And I think this is probably something that might have messed you up and could prevent a lot of these optimization mistakes that you're making. So you're walking through the example, and I would have liked for you to be able to roughly define what variables you are working with, or at least some kind of design here. Because notice here, you're walking through it,
Mhm.
don't really make an effort to show me what exactly is going to happen. So it's like I understand. So at this point, what I'm thinking is you have some rough idea of what you want to do,
Mhm.
but there's nothing concrete here, and just kind of feels like you are waving a magic wand and hiding all the details.
Okay, so would something like instead of just saying that I would be returning the heights, would having like a height variable and then changing it as I'm walking through the example be more effective?
I think actually just writing out very briefly what you're going to do, like as a pseudocode, and then say what approximately what values you're going to be using would actually would be extremely helpful here. I think.
Okay.
Um, So that way, like I know what you're doing, you know what you're doing, and you don't have to try and figure this all out in your head.
Okay.
Um, Sorry, go
Sorry
ahead.
to interrupt, but I thought I kind of did that a little bit, like in the little like bullets right above the example. Like I know it's not as linear as like actual code, but I thought those were like some ideas because I've been trying to balance having enough time to um like having enough to actually code the problem and not writing too much pseudocode beforehand. So it's something like the full 4 bullet notes I had before not be effective.
I would say it's the quality of the notes, really.
Oh,
So I'll show you what I mean in a little bit, and I'll show you how I would have done the problem. But it's really like if you look here, you only spend about 12 minutes talking about the problem. And I would argue that if you had a clearer idea of what you wanted to do, you could easily get the optimal solution in like in an additional 8. So that would have only taken you 20 minutes
Okay.
to do the problem. That's at least my argument here. And I'm going to show you why. So you have this balance tree, you have this height here, and you already knew it. And then I had to point out this max here.
Mm-hmm.
I think this is something that you might struggle with in the future.
Mm-hmm.
Is that when you're dealing with like these functions calls, these aren't just magic wands. They take a input and give
Mm-hmm.
you an output. So it's very important that you become very mindful of what these inputs and outputs are. So it's those little details that kind of trip you up. So you realize, hey, wait a minute, I need to pass in integers. I need to get back integers.
Mm-hmm.
So right here, I'm cool with this, right? And so now you should also need to return true, but that's whatever. So right now you're at like 17 minutes, And so I think this is fine. And I think if you really understood what optimization you're going to do, you could just write the optimization in like 3-4 minutes, and that would put you at 20 minutes for the problem. So the fact of the matter is that you're kind of like trying to like hack your way to the optimization.
Mm-hmm.
And I don't even think you fully understood what was supposed to happen. I think the key part of this was that you didn't know how to return two values or handle like two values.
Mm-hmm.
And so this is a tip I think that's going to help you for any recursion, is that if you find yourself that you need to return a integer and plus an extra value, then you could just send it back up as a pair, as a list. Although personally I prefer pair because that way you explicitly define what values you want. So in this case, the pair would just be the height and if whether or not it's balanced. And then inside the recursion, you would just do a check for that value.
So if balance is still true, then keep doing this. If it's not, then stop.
Exactly.
Oh.
That's literally all it would have been. In fact, and let me show you let me actually write that out. So first things first, I did say I was going to show you how I would have approached the problem. So thing I would have done here is that recurse through tree, and then look at left height, look at right height. If if the height is unbalanced, then return false, and with height. Otherwise, return true with height. Something like this.
Mm-hmm.
And so this would basically outline my algorithm, because now I identify, hey, I need to return two values, and I think you touched on this actually very briefly when you were talking about the global flag. And even then, if let's say we took the global flag route, right?
Yeah.
Oops. So let's say, oh shit. So let's say we took the global flag route.
Mm-hmm.
So then I would just say, look at left, look at right. If the recurse through tree, actually, and then here, let me actually be a little bit more specific. So look at left height, if unbalanced, balanced, return false. And then same would look at right. If unbalanced, return false, So this would be my general algorithm. And notice how quickly I kind of wrote it once I knew what I was doing.
Mm-hmm.
It didn't really take that long. So let's say we had a flag here. So instead of returning false, it would just be look at left height. If flag is set, return false, returns 0. I could just return whatever value, -1.
Mm-hmm.
And then same for right. If height is unbalanced, set flag, return -1. Otherwise, return height. No matter which way you cut it, this was done pretty quickly.
Mm-hmm.
And that's only because I had a very clear idea of what I was doing, and it didn't really take that long to do. Most of the typing was actually this here, which is just a copy paste of itself.
Mm-hmm.
So, and then going to modify. I think if I didn't know to do that, and let's say I went for your initial solution and just did the naive solution approach, right? then I would just follow my code here and then say int left equals the height root dot left, assuming the global flag, because I think this is the one that you're more comfortable with. If balanced, if not balanced, return -1. Right equals height root dot right. Same if balanced, return -1. And then you do if absolute height root dot left, or actually I have if left minus right greater than 1. Then I would flag balanced equals to false, return -1, and then return what's it called, max of left right plus 1.
Yes, I think that was kind of the approach I was trying to get at. Except I wasn't returning the negative one, like if it wasn't unbalanced. I think it was kind of combining those two values together when I was doing the calculation for like the height differences in the subtrees.
I would say that your let me simplify. I think your problem actually is right here. So you notice here that I broke it up into left and right. That way I could do the evaluations on each time. And this is what I was talking about. Like the fact that you combine the steps of the recursion, you have the recursion here, and then you had the if immediately followed by the if statement. So there was no chance that you could have done this evaluation. So that was the big mistake, is that the fact that you combine the steps. Does that make sense?
Yeah, sorry, I'm just like typing this down.
I think and also the fact that if you just broke this up and then just did the checks, that would have gotten you to the exact same solution, even if you didn't do the design step.
Yeah, that makes sense. Yeah, I think I was a little bit too focused on seeing them together as opposed to seeing it as like a recursive policy for like a nodes, a nodes like left and the nodes right, and then seeing them together afterwards.
Right. And I was like kind of constantly trying to direct your attention towards this. Like, hey, the fact that you do the recursion inside the same step as the if statement was messing you up. And it's like, I don't think you ever dug yourself out of it. And so just having that preconceived bias was bad, but that's why we're here. We're trying to fix that. I do also think that being cogent of like recursion, being able to understand it as something that you put in values and then you get out values of a certain type, that you translate your inputs into outputs. I think that's also going to really help you, because that way you can have the insight to really break apart your recursion as you need it. Like in fact, like if this left and right were pairs, then you could just say left dot first or something instead of balanced. But that's I think really going forward, think of recursion as just another way of handling a function call of getting inputs and outputs.
Okay, that makes sense. Yeah, thank you so much for the really helpful feedback. I really appreciate it. And I think it also kind of makes me more like aware of how I'm doing like functions that I feel like I'm familiar with, since I do feel like familiar with like using height as like, combining the subtrees, but then looking at them through like the recursive policy of like evaluating each subtree differently. I think that would definitely be something to keep in mind. How would you evaluate like my overall understanding of the fundamentals of like trees and recursion?
Probably 7 out of 10. I think you understand the nature of trees by like a very textbook definition. And you understand what needs to be done. But where you fall flat is basically your ability to understand that a tree is more than just its node and children. There's a left subtree and a right subtree. And I think your approach, at least what the tree looks like in your mind, is that the left and right are one unit. Is that about right?
Yeah, I would say so.
Yeah. So think of each children as its own independent node, because in the future you might not necessarily be dealing with a binary tree. You could be dealing with an n-ary tree where you have like 3, 4, 5, 10 children. And each one of these children represents a possible path or possible recursion call that you can make. The other thing I think would help is like, yeah, I think going into these interviews, not being as heavily focused on design is definitely something that should be considered. But at least as an exercise when you're first starting out, and I still feel like this is something you would really benefit from, just doing this design is just so you can break down the problem is very useful. But
Oh,
again, don't marry yourself to it when it comes time to the on-site. Just do whatever comes naturally. Don't focus on like, oh, I need to execute this detail. This is just an exercise for you to be able to break apart a problem.
okay, I think that makes sense. Just because I've been trying to like experiment with whatever would be like time efficient, but also thorough.
Mm-hmm. Right,
Uh,
because when it comes to the interview, I want you to be as natural and relaxed as possible. Don't worry about getting through a checklist because I think that's the fallacy that a lot of people run into. They're like, "Oh my God, I must do this first step, and then immediately after, I must follow the second step, and then and so on and so forth." Really, the information I'm giving you right now are guidelines. They're heuristics at the end of the day because everyone has their own way of solving problems. But this is just these exercises are the way I think is the best way to train how you think, having a very clean approach. And the closer you really get to this when it comes time for interview day, the better off I think you're going to be.
okay, that makes sense. Thank you so much for the really helpful feedback.
Yeah.
Would you say that how would you evaluate my communication throughout the whole process?
I think your communication is very good. I think you were able, like when I tried to ask, clarify your thinking, you're able to present it. You were able to respond very clearly, very easily, and I don't really see a problem in that. I think you communicated exactly what you were thinking. It's just that what you were thinking was wrong.
Okay, that makes sense. Um, would we have time to do one more question very quickly?
Let's see. We have like, yeah, we have like another 30 minutes, but I understood you want to do like a behavioral question as well.
No, I don't think so. I think I might want to just practice on a technical question. I feel comfortable-ish with behavioral, I think.
Okay. Do you want the same kind of problem or do you want something else?
Um, I think something else would be better.
Okay. Um, do you want so and I know you said that you didn't really have tree or graph problems. And I feel like if we did a tree or graph problem, you probably run into the same issue.
Mm.
Um, and you got a heap and stack problem from Capital One, but you felt like you kind of stumbled a little bit, but at the time because you weren't familiar with them. So let me ask you, what do you between heap and stack and array problems, which one do you want to do?
Um, I don't think stack. I think maybe something with a heat.
Okay. Um, Actually, this original problem that I was going to give you can be solved with a heap, but may or may not be optimal. Actually, now that I say this, it might affect the way you view the problem. But it's a little bit more open ended than what a lot of people. It's a little bit, yeah, it's a little bit more open ended than what you might think. So actually, it's a pretty good problem for me to give you.
Okay, that sounds great.
Okay. So in the time we have left, I'm going to give you this one, and I'm going to see how far you can get.
Okay, that
So
sounds great.
So I want you to design an algorithm that searches a body of text for a list of keywords. Return the chunk of text that is the smallest length that contain all those keywords.
Okay.
And don't worry if you can't solve it. This is literally I would say medium to hard problem.
Okay. Will I be given an input test case?
Yeah. So let's say I had cat and hat, and then
Mm.
say the cat in the hat book is a great story about a cat. So so in this particular example, I would want you to return the cat in the hat because it has cat and hat in it. So because this the cat in the hat equals 4. But then there's also hat book is a great story about a cat. is a length of what? 369. So you would not use this because let's see format. Strike text, strike through. Strike through is Alt Shift 5. Okay. The heck, that's so weird. Okay, so this would not be returned because it's too long, but it does contain hat and cat. Just
Yeah.
the order I necessarily gave it in. So
Okay. Okay, so I think that gives me kind of a better idea on what the algorithm is doing. Am I always guaranteed to have the keywords in the text?
you're not necessarily guaranteed to have those words in the text.
Okay. Um, so I think that going off on like a naive approach on, I'm just gonna go and kind of copy and paste this. But I think a naive approach on searching for the words would probably be just like iterate through the entire list and then perhaps keep a hash map of the words.
Okay.
Um, and then each entry could be like the keyword, and then they could all be set to, I could set all the booleans to false. And as I'm going through the text that's being given, then once I reach that, all of um, yeah, once I reach that, like all of the words are matched. Um, at that point, I could go ahead and return it. But because I'm trying to find the smallest length, I think that would have to be modified. So I think that once I reach um, reach a keyword, that's when I kind of want to keep track of the starting index
Okay.
for the substring.
Mm-hmm.
Well, not the substring, but the string within. I'll just call it substring in this case, but like the string within the text. And then I think that I also want to keep track of um I also want to keep track of like how many. So I want to kind of count number of matched words.
Okay.
And once yeah, because I think that going off of like a naive approach on this, like ideally I just want to reach the point where I can have all of the words within, let's say, like the window size from the start to the end, right?
Right. I will say that make sure that it contains all the keywords. So it's not number of matched words. I understand what you're trying to think here. But every single word in that list needs to exist in the substring you're looking at.
Yes, I think that makes sense. I think that was like a wrong choice of words. Um but essentially what I want to do is that I want to keep like think about this as a window size where I want to increment the window size in the text until I reach a point where all of the keywords are in there. And that once I reach the length where I have all the keywords, like in this case, that would be from the cat in the hat, right? But I know that the isn't really necessary. So then I could kind of because I'm working with like the start and end pointers for the starting and ending um indices for the substring, I could kind of keep incrementing like the start index in order to minimize that window while still maintaining the size while still maintaining that all the keywords are in that window.
Okay, so you're gonna have a static window size.
Yes. Um, well, I wouldn't call it, would I call it static? I'm not quite sure if I would. Because once I kind of minimize it to the point where I still have all of the words, then I'm going to start incrementing it again and then seeing the other windows and then seeing if that's the minimum window that I have. So I think that's kind of a rough approach on how I'd go about this problem. Okay, so essentially, I'd want to use start and end indices, start and end pointers to track the window size, and in the window size, maintain get all keywords in that window. And then once the window contains all of the keywords, then I want to kind of increment my start pointer until the minimum window, until reaching the minimum window. And then once I reach the minimum window, then at all of those points, I'd want to check if this is the max, this is the minimum length so far by using the start and end indices, starting and end pointers.
Mhm.
And then I think even after I reach the minimum length, as I'm iterating through the string, I still want to continue incrementing continue incrementing the int as I go on because this process will like repeat. And then I think the issue becomes with how to check that all of the keywords are contained within the substring.
Okay.
So in terms of checking for that, okay, so I'm thinking that what I could probably do is right now I'm gravitating towards like a hash map because I know that's with that I could use like constant time of lookup to see if something's there. But I'm trying to kind of maneuver like what I'd want to be in that hash map. So if I had like cat and hat, let's see if what I could do is once I see a word that's contained in once I see a keyword in the text, then I could kind of add that. So once so see keyword in text, and then I could do two things, I think. So one thing could be that I could add the keyword to a hash map.
Okay.
Um,
But then the hash map would be mapping what to what.
um, I guess I mean I don't think the value would matter as much with this implementation. But for this instance, I could just call it like the count. Like it could just be the count, let's say.
Okay.
So another thing about the input is that would I have a duplicate keywords, meaning that I need to find two cats, two hats, or am I always guaranteed to have unique keywords?
Mm, let's put it this way. For now, let's assume that all the lists in the keywords are unique. Yeah, let's keep it simple.
Okay. Okay, so I only have unique keywords, so that means that um mm, Um, actually, actually, I think that what I could do is I could initially, if we are dealing with all keywords being unique, okay, then I could initially have like a hash map with all the keywords. Like I could initialize my hash map with that. And then if um, the keyword is found in the text, um, then because like all the keywords have a value of 1,
Mhm.
then I could make it have a value of, I could decrement its value, hash map with all keywords, where the keywords, sorry, just would be mapped to the count,
Okay.
right? So meaning that all of them would be equal to 1. And then if the keyword's found in the text, then I could decrement its count. Um, so then it would be 0 for the first occurrence.
Oh, I see. So your map is like, oh, this number of keywords. Like we found, uh, like we need one instance of cat, we need one instance of hat, and if you find that, then you decrement it to 0.
Yes, and then that way I could also keep track of like excess words because if I have any negative values for a key,
Mhm.
that means that um, my window has more than one occurrence.
That's fine. That's fair. I think that's a good choice.
And then um, in that case, um, this would inform how I'm doing my calculation for the window containing all the keywords. Because once I reach the minimum window, like as I'm trying to kind of minimize that window even more, like let's say that, in this case, I have my start. Let's say I've gotten to the point where um, I have cat and hat in my dictionary with a count of 1.
Mhm.
Um, and then once I get to this point where I'm at index 5, I see that I have all the words there. And then once the window contains all the keywords, I increment the starting point and then I see if I still have a match. And I do have a match.
Okay.
And then I increment my starting point again. And at this point, I see that I don't have a match. So at that point, I stop trying to increment my starting point within I'd say this would probably be like a while loop.
Oh,
So while a while loop inside like the main iteration, let's say, then
okay.
I break out of that while loop and continue just going through the process of like checking if this is the max length so far that contains all the keywords. Well, actually, this would only happen inside while it still contains all the keywords. And at that point, I just move on to the next word in the text. And then in that case, I think I'd also want to probably have some sort of like match
Mhm.
counter where I count the number of matches
Mhm.
of keywords. Um, and I only increment my match counter if if I see that like keyword is in the dictionary.
Okay, well, keep in mind your entire hash map is counter for all your keywords. So what exactly is this match counter?
Oh, that would just be like a variable.
Okay, but you're already keeping track of the number of times that you've seen the keyword effectively in that map. So like if I gave you
Mm-hmm.
cat and hat, you already have counts for cat, counts for hat. So what exactly is this match counter?
The match counter would be counting how many keywords I've seen because this is how many times I've seen each keyword. But I would need to like see each keyword like at least once. I guess I could also probably just keep track of the length of No, that wouldn't work. I was gonna say length of the hash map, but um, if all the values would be like one or zero or negatives. So if I count the matches for the number of keywords, then that would be like um, if the keyword count is one, and this like the ith word in the text is in the dictionary, and that word's count is one, then I want to increment my match counter. And then once the match counter reaches the length of like the number of keywords that I have, that's when I know that I've reached um, all of the keywords within my window.
Okay, so you're basically having a separate. Well, then how do you know which keyword you're missing in your variable match counter?
Well, I wouldn't know exactly which keyword I'd be missing. Um, but like the way that the match counter is working is that it only increments if the keywords count is one. So if the keywords count is zero, like okay, so like if hat, sorry, is it? Yes. So like at this point, right? Like if cat, so let's say that instead of being there, I saw cat over here.
I
So
see.
if cat now has -1, and sorry, that would be if cat is zero, and what is that? That is the second, and the second string is cat,
Mhm.
then nothing would happen
Okay.
because it would only happen if cat is one and the ith string is cat, then I'd only want to increment the match counter. Um, because I know that's like the only case where I'm seeing it for the first time. Um,
Oh, I see what you're saying. Okay, so the real match counter is the number of unique keywords that you've encountered so far.
yes, yes. It's just kind of the number of matches of the keywords. So, and because of the hash map, um, essentially telling me like one means haven't seen it, zero means I've seen it once, and anything below zero meaning I've seen multiple occurrences of it.
Okay.
That kind of let me know if I should increment the match or not. And this can also be scaled up to seeing duplicate keywords because it wouldn't really matter if it's like one or three or five, because as long as I see zero, that means like I've had all of my matches. So as long as in that case, as long as the count is greater than zero, then the match would increment.
I see. Okay. Yeah. So, all right. So I'm curious to see how this plays into your algorithm.
Okay. Should I begin coding now?
If you think this is good enough for me, if you think this is good enough, then sure.
Okay. I'm a little bit concerned with the time.
Don't worry about the time. Again, I'm just really here to see how far you get.
Okay. Um. So this is um min string, let's say, and then the only parameters I'm given are text and keywords.
Mhm.
Okay. So I'll begin by initializing my dictionary for the keyword. So for iterating through all the keywords, if if the keyword isn't in the text, then I would just, because we're going with the assumption that this is only for unique keywords, I just set it to one.
Mhm.
And then I'll set match equal to zero. And then I'm iterating through the text.
Mhm.
And if So if the text is in the dictionary,
Mhm.
and the dictionary's text I, so if the I string in the text is in the dictionary, meaning it's a keyword, and its value is equal to 1, I'm actually just gonna put everything here just so the indentation doesn't get messed up. Then I increment the match, and then if the match equals the length of the keyword,
Okay.
then so actually that wouldn't be an if statement, that would be a while statement, because while the window contains all the keywords, I'm essentially just checking to see if this is the key length so far.
Okay.
If this is a minimum length so far. So I'll also call this the min length.
Whatever happened to your pointers?
Oh, yes. I totally forgot about that. Thank you. Okay, so at each point, I'm really just incrementing end. So while and this is where the pointers would come into play. So while the match is equal to the length of the keywords, and then I'll just set the minimum length to the length of keywords plus 1, because if it's still that length, or I guess I could also set it to -1. If it's still -1, that means like it's not in the list. The keywords aren't in the text.
Okay, so wouldn't it just be better to have that as 0?
Oh,
Because 0 means no words.
okay, so while the match is equal to the length of the keywords, then I want to check to see if this is the minimum length so far. No, actually, it wouldn't be better to keep it at 0, because 0 would always be like the minimum length so far.
Okay.
So then I'd actually want to keep it as like length of keywords plus 1, because if it ends up being length of the keywords, that means the entire. Oops, sorry.
But
If
doesn't
it
that mean
being
that
the text, that means that the keywords are contained in the entire text. But because
doesn't that mean you're assuming that the keywords are in the text?
no, I didn't quite finish explaining that, but I was saying that because it's length of the text plus 1, that means that if by the end of this iteration, that would also be nested in there. If it's still this length of text plus 1, that means it's not in the text. So then I'd want to return 0, because it's also possible that it can be in the text, in
I
which
see.
is valid.
Okay, fair enough.
And that would be like the maximum length so far.
Okay, it's just whatever you set the value to. That's fine. Sure.
Yeah. Okay, and then the minimum length would be the minimum of the minimum length. And that would be end minus start plus 1 for like the length, accounting for like the index and length. And then at this point, I'd want to begin minimizing it. So I'll call this like the old start is going to be equal to the start. So what I want to do is so the so essentially, like for the old start, I'm going to be decrementing its count.
Okay.
And then if So if this now equals to 1, that means that I don't have any current matches for it. Because if it equals 0, sorry, I'd be incrementing it, because if I already start off with a negative value and I increment it and it's still negative, that means in my window I still have access characters. If I have 0 and I increment it 1, then that means I don't have any values corresponding to it. And if it goes from being negative to 1, that means that I still have 1 value that still corresponds to it.
Okay.
So if it's 1, that's when I want to, and that's where the match comes in, because match has to be equal to the length of the keywords.
Okay.
So match would be also decremented by 1.
Okay.
And then it would just go back up again, and then it'll like break out of that loop. And I think that was essentially what I had in mind. And then if the minimum length is still equal to this value, like the invalid maximum length, in that case, I just want to return 0.
Okay.
Otherwise, I'd want to return the minimum length.
Okay. Yeah. So approximately, let me run through this really quickly.
Mhm.
Okay. And yeah, man. Okay. Text dictionary. Okay. So you're looking at the text, and then if the number of unique matches that you get equals to the length of the keywords array. Okay. Your minimum length, you're gonna do the minimum length comparison. Your
Mhm.
old start is equal to start.
Oh, sorry, I also forgot to increment start in that.
Mhm. Okay. So then your old starts that you remove the old starts dictionary to count the fact that you're advancing that old start pointer, the start pointer. Um, if dictionary old start equals to 1, that means that 1 being that, hey, I need to have 1 more of this, then you've lost the unique count. Sure. If text dictionary. I'm gonna say I think you forgot something here.
Oh,
What if you run into multiple words? Like say, for instance, like you ran to cat and you ran to cat again. How do you handle this? Did you forget to decrement the
sorry, this would. Yes, I forgot to decrement it over here.
Well, again, that only occurs if you've seen. What about if you see cat the second time? So, anyway, so I have enough to actually talk about, by the way, but it's a lot of these issues aren't really just stem from the same thing, actually. So no matter what the bugs are that you're coming up after this, I think it still stems from the same issue. So, let me go over them.
Actually, interrupt, but I don't think if I understood that bug correctly, I forgot to decrement it here, but I wouldn't, if I ran to it, so the entire bug for that would be that if I see text in a dictionary and it's not equal to 1, then I'd still decrement it, but I wouldn't match it.
Yeah. So then, wouldn't you just do something like this or
Yeah.
something like that? Yeah, it wouldn't be indented.
Yeah.
So yeah, so let me go over things.
Mhm.
So I think that again, you came with a pretty good like a unique, I wouldn't say unique, but a what's it called, the naive solution pretty quickly, and I
Mhm.
think that's fine. I think one of the things that really that like you can find, I think you kind of like slapping code here, like with this and it's like, oh, I've got this. Oh, I've got this.
Mhm.
And I think it really came down to like this design. I understand that what you're doing, you're listing out everything you need to do.
Mhm.
And I think it definitely got you a lot farther than I would have expected. I think that's a really good sign. It's
Mhm.
just that these little details, these what you need to do at each step is you don't you messed up on that because you didn't define that in here in the pseudocode. So going back to like the previous problem, notice like how I did it. I said exactly what I was going to do at each step, even though it's like not pure. Even though it's not purely code, it was just like this is exactly what I want to do.
Mhm.
And the difference between what I wrote in the previous problem and what you wrote here is like you kind of have a jumble of ideas, but I would like to see like just you be a little bit more atomic about it. Just like say exactly what happens and what you're going to do. Like here, like you describe, you have hash map with all keywords. If keywords found in text, its count to 0. If I would say this is a little bit confusing to say because it directly counteracts what you said here of negative value. It's these little small things I think when you go to design that is tripping you up, but these are not. It's just like be very be aware of that. I would say also be a little bit more atomic about what you mean here by variable match counter. This should be amount of unique.
Mhm.
It's like it's again, it's like being very atomic about it. I don't mind what you did here though. I think it's you're going off of just sliding window algorithm, and I think that's perfectly fine. I think I would have done exactly the same thing. And then try to do this. Of course, there is a more optimal solution to this, but that's a little bit nicer. But I think overall, your solution is still very good. Um, uh, but yeah, it's just that you forgetting this stuff here, is because you didn't really specify it up there. And for problems that can get very hairy with a lot of nuances like this one, you will find that you're going to miss more and more of these. So small things like these are not going to, it's not going to be like that bad against you, but it's like they can add up very quickly.
No, I definitely see that. When like I'm getting stuck on like something like old start, I forget about incrementing the new start. Uh,
Exactly.
and then I think something else, I felt a little bit reluctant. Like I didn't really want to go back to the notes. Is that something that's considered bad? Like if I still refer to my pseudocode as I'm writing it?
No, I mean, because to be honest, when I do it all the time, because when I'm writing something, I'm thinking about the implementation. I'm going to forget what I wrote 10 minutes ago, actually, and I'm going to forget exactly what I said 10 minutes ago. I'm going to admit my memory in general is absolute trash. I'll tell you, I'm the most forgetful human being, and this is why I actually use pseudocode very heavily. In fact, if you watch like some of my YouTube videos, I still refer back to the pseudocode when I go to write the code and when I go to try out the test my solution when I post those videos of me doing problems. And you can still see I do it like relatively quickly within like 20-25 minutes.
Okay, that's good to know. Um,
So I would recommend you watch like some of those videos, and then also the one where I told where it says like, oh, do this to master recursion. I think you would benefit a lot out of that one as well.
okay. Yeah, I'll definitely take a look at that.
Okay.
Um,
Also one other thing, really quickly, this choice right here, custom values.
where?
Right here, I underlined it, where I mark custom values in the code. Just do a Control F for custom. Do you see it?
Yeah, I see it. What do you mean by that?
So usually when we talk about like some default value like this, we
Uh,
never really do a custom value like this where it's like, oh, this is very specifically length of text plus 1. We
mhm.
usually refer to something like math.max as a convention. So that way we know very specifically, hey, yeah, because this is an absolutely unreasonable value when you immediately read it, there's no way we're going to trip ourselves up.
Oh, okay.
Whereas if we read something like this, it's like we have to actually think about it. We have to think about, oh, is this a reasonable value? Are we not possibly conflating this with a actual result?
Mhm.
And so this is like, that's why when I read this, for someone who's not familiar with the problem, they're going to say, hey, that looks like a code smell. That's why we almost always we refer to max as a default value. It's just so that way someone else who's reading the code can easily understand it and not be concerned if it's going to be a valid or invalid value. So this, like the value you chose here, only really makes sense when you think about the problem. Whereas someone who's immediately reading it, I can already understand math max to be an unreasonable value. Does that make sense?
That makes sense.
Yeah, it's just small little giveaways like that that really differentiate with really like junior developers and senior developers or people who are more used to like a production code base. It's just the readability of it. But overall, the one thing I think you would get a little bit more value in your practice if you were a little bit more atomic about your design, so it doesn't trip you up later on. And then, but that's really it. I think you're in a pretty solid position. I think if you spent like maybe like this winter break really drilling on making your how to say your flow of work, your workflow, to be a lot more precise. I think you really could do very well on Amazon and Facebook. I mean, not Amazon, but Microsoft.
Precise. Okay, that sounds really great. Thank you so much for the feedback. Um, and then just to kind of clarify, so right now, if you were to kind of overall test how I'm doing data structures and algorithms overall, it would be like a so-so.
I would say 7 out of 10, honestly.
So,
It's not. It's like you have the basics down and you have a very good understanding of them at a textbook level. It's like these small little
nuances.
nuances, yes, like things that you only really get to once you fully understand engineering and what it entails, like all these little trip ups and how to prevent them, that I think you'll really start to um, really come into your own and become much more fluent at these problems. Because from what I see, you're still approaching this in a very textbook manner,
Okay.
but and you're like listing off the properties, but you don't really set yourself up. You don't really assemble these properties into a workable structure that will prevent you from making mistakes. And it's because you just list off the properties that you make these mistakes. So it's pretty normal, I think. But you're definitely a lot better than a lot of other people I see.
Mm-hmm.
So don't feel too discouraged. I think you're doing very well.
Okay, thank you so much for the really helpful feedback. And based on like your evaluation on like my understanding of the fundamentals, since I am going for like internship positions as opposed to like new grad or full time, do you think that obviously like it would definitely be best if I had like a really great understanding of these topics in depth, but do you think the understanding that I have of the basics would be sufficient enough to kind of let interviewers know that I'm like,
I don't think textbook understanding has ever been a problem with anyone, to be honest. I'd be very surprised if that was the case. Almost like 90% of the issue always comes down to execution of the problem, more so than actually understanding these data structures and algorithms. And so because of that, I think you should focus less on whether or not you can memorize time space complexities or every single little property of the data structure. I would focus more on being able to execute on that a little bit better. So to reevaluate the question that you just asked me, how would I evaluate your execution and your chances of getting an internship? I think you have a pretty good chance. But as always, what I try to do here is always show you what you can do better.
okay, that sounds really great. Thank you so much for the really detailed feedback and answering all of these questions that I had. I definitely got like a lot of value out of doing these practice problems with you and then seeing more on like where I can really hone in on my areas of weaknesses.
Mhm.
And I just really appreciate like you taking the time to do all of this as well.
Yeah, for sure. Keep me posted about the internships.
Yeah, I definitely will. Thank you so much.
All right, for sure. Take care.